In this video, we're going to look at some examples of the application of the Pythagorean theorem to help us solve for the length of a side in a right triangle. So in this particular case, we have this right triangle, and I need to find the value of x. And we notice that x is the length of the hypotenuse because it's opposite the right angle. So we would know then I could write the equation 10 squared plus 5 squared is equal to x squared. The sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. 10 squared is 100. 5 squared is 25. So we would see that x squared is equal to 125. So x would equal the positive or negative square root of 125. Notice I did not put the positive or negative there. I can see x is the length of a side. It can't be a negative. Now, through my process of finding the greatest square factor of 125 or using my prime factor tree, I can simplify then to say x would equal 5 times the square root of 5. There's our first example. Here's a second example. In this case, x is the length of one of our legs. We have a right angle here, so 12 is the hypotenuse. So in this case, we could write an equation 8 squared plus x squared is equal to 12 squared. I could have had the x squared first and then the 8 squared. Doesn't matter. So 8 squared is 64. 12 squared is 144. If I subtract 64 from each side of our equation, x squared would equal 80. So x would equal the square root of 80. I don't worry about the negative square root in this case because x is a length. Lengths can't be negative. Then through either our process of looking for the greatest square factor of 80 or our prime factor tree, we could simplify the square root of 80 to be 4 times the square root of 5. Now, in the next problem, we're looking at this a little bit differently. We could still use the Pythagorean theorem to find x, and that wouldn't be a problem. But our directions here ask us to use a Pythagorean triple to find x. And we saw some different Pythagorean triples in our notes. And remember, if we multiply those Pythagorean triples by a number, those also make right triangles. So I don't have any of those Pythagorean triples that have a 14 or a 50 as they're written. However, notice that 14 and 50 are both divisible by 2. 14 is the same as 2 times 7. 50 is the same as 2 times 25. We do have a Pythagorean triple, 7, 24, 25. In this case, 2 times 25 is the hypotenuse. Okay, so if I look at what's in parentheses here, let's say, okay, x has to be 2 times something. 2 times 7. 2 times 24. 2 times 25. Because this triangle, that happens to be a right triangle, would be similar to a 7, 24, 25 triangle. If they're similar, they have to have congruent angles. So a 1450, and then we would see then that x at 2 times 24, or x equals 48, would also be a right triangle. So having those Pythagorean triples handy, remembering that multiples of those numbers also produce right triangles, can be very helpful.